in beautiful Maui, Hawaii. Back to the action. So, where we left off, we were talking about here, we were talking about, what this plan view piece means and our missed approach. Now that we have our missed stuff figured out, now let's start thinking about how we don't miss, okay? So if we look down here in this portion of our plan view and we look at our initial approach fixes that we have available to us that allow us to begin this approach. We have our transitions coming in, one here from Lanai. We have another transition coming in here. This is still coming in here off Lanai, off this transition here. And then we have our target, which is camps. Camps, this intersection is where we will ultimately begin the approach. So down in the bottom part, Harpo takes us here to come to camps. Keiki takes us from that intersection here to camps. So if we're coming in here from some of the other islands this direction, Keiki may be the most logical place for us to begin our approach. And that would be the initial portion, our initial approach fix that we would list whenever we are loading our approach on our G1000. It'll ask, where do you want to begin this approach? Well, if I'm coming in from the north, the northwest, I'm probably going to choose Keiki, unless there's some compelling reason for me not to. If I'm coming in from the south somewhere, let's say I'm coming in from the Big Island, then I'm going to probably use Harpo as my initial approach fix to begin my approach. Okay, so that's why those things are there. So we can see here that these intersections have been established by ground-based radio navigation, or VOR. They've got the little triangles there. So now, as we look at this, we see the initial approach fix at Keiki. We can see that this is from the Lanai VOR, and we see this kind of an image here. It's like a big D with a number in it. D standing for distance, the number standing for nautical miles. So what that means is that it's been 17 nautical miles from the Lanai VOR to get to that point, okay? And so that's kind of where we have, this information. And from over here, from Lanai, it's been 26.6, D standing for DME. That distance measuring equipment, or that distance from a particular point. In this case, it's from the VOR. Now, as we look here, I'll take these out. As we look here at this information into our feeder, we can see they want us here at 3,000 feet, okay? We're going to be flying a course roughly of 09 or 5, okay? And remember I said course, not a heading. Because depending upon the wind, you may have that airplane pointed in several directions, but it's that course of roughly 09 or 5 to get you over here to camps. And the distance between Keiki here and camps is 4.4 nautical miles. So if you're traveling at a ground speed of 120 knots, you have just outside 2 minutes to get everything ready to go, okay? 2 minutes. If you're coming in here from Harpo, they want you at 3,000 feet. You're going to be flying a course roughly of 275 degrees, remember, not a heading, and it is 5.1 miles. Excuse me. And so at a ground speed of 120 knots through here, you have just over 2 minutes to get everything planned to set for your approach. Okay? So then you have to get to camps. Well, before you get there, you see these little things here that kind of cross, and you see these deals here, lead radials. So what you can do, remember I told you that you can set your VOR in one of your second navigation systems, and what you can do is you can set this up to give you notice when you're crossing this lead radial here and here, as you're flying this direction or this direction. That gives you a heads up that here pretty darn quick you are going to be making a turn coming in here to accept your final approach course. That's what it does, is it gives you some time to be able to make that work. The faster flying airplanes, it works a little bit better for them. Kind of the slow flyers, you're probably not going to start your turn until you're closer to this, is normally where you're going to be because you're flying slower. But it gives you that information that you're going to be starting to make a turn here to intercept your final approach course, okay? And once you're set up here on your approach course, this is what you're going to be flying, an approach course of 0 to 4 degrees. And you're going to want to make sure that in your, that on your system, whether it's your HSI, or it doesn't matter if it's on a G1000 or just a regular HSI, that you're set for that approach course of 0 to 4. That's what you're going to dial in to make sure that that is your approach course. The G1000, if it's updated and everything on it is accurate and calibrated, it will give you the final approach course of 0 to 4, and they should match, but you want to check just to make sure. Okay? Now, before we start flying this final approach course, you'll also notice this out here like that. This is another area, another holding area. This is an area that has been established where they could ultimately put you to hold. Now, they may or they may not. It depends. They used to have you out here to hold, but right now they have sort of changed things, as I'll show you in a minute, where they kind of don't have you coming out there to hold. So it's going to be interesting to see what happens here. I sort of anticipate this hold to stay out here for a while longer, but you just never know. And it shows you here from this intersection at Camps. This takes you then here on the IOG 17.7 miles, okay, that will take you to the localizer. Now you're going to notice that the localizer is going to be at the far end of the runway. So 17.7 is not going to be to the approach threshold, it's going to be to the far end of the runway, and you'll see that here in a second. You'll also see that on the 09 or 5 degree radial that from the Lanai VOR, it is a DME of 21.4. Why does it show those things out there? My gosh, Mr. R, we have a G1000. It does everything for us, including cook our breakfast and do our taxes. Well, some airplanes don't have G1000s, and they have some of the older style instruments, and you have to know where that intersection is, not just because this fancy television shows me where it is, but some people have to actually do the math. And with this, this is where it shows you the distance from that particular VOR on a particular radial. That's how the intersection is established, is with that information. Okay? So, understand that. Now then, we can see also here at Harpo, I'm going to use Harpo as an example again, is that we talked about the altitude they want you at, the course they want you to fly, the distance, but we see something here that says no PT, no procedure turn. In some cases, when you're flying to a particular intersection, they want you to fly a procedure turn that will get you turned the right direction to establish yourself on the inbound approach course. In this case, they don't want you doing that. In this case, they don't want you coming in here, flying back out, coming back in, and doing this. What they want you to do, they want you to do this. That's what they want you to do, okay? So that's kind of how that works. Once you're established inbound, they want you here at 2,400 feet for this first, this intermediate segment here on a course of 024, and it's going to be approximately 9.2 nautical miles from this intersection to this intersection of Tebbs to get you down, okay? And then from Tebbs to Nowak and all the way down the pipe to land right there on runway 2 in Maui, okay? These are the basics of a plan view and how a plan view works. letting you see from the top down what does an approach look like from above. Now we're going to look at it from a profile standpoint. If you're standing on the ground and you're looking out into space and you're seeing, okay, here's what it's going to look like as we come down here, and showing you the vertical elements of it as opposed to just the horizontal elements of it. So now let's take a look at the profile view. To look at the profile view, we're going to scoot this thing down, and here, well, what did I do? I lost my pen. Why did I lose my pen? There we go. Whoop, well, hang on. Goodness. Oh, dropped my pen. Number 7. This is your profile view. So your profile view shows you, here's 3,000 feet, and they don't want you below that, okay? And notice this, 3,000, 3,000, until you get to camps. Once you get to camps, you can descend then from camps down to 2,400 feet, but no lower, until you get to TEBS. Remember TEBS out there? Let me get you out there. Remember TEBS? Okay. Then from here, you see the little Maltese cross here. This is going to be at TEBS. This is going to be our final approach fix. This is going to be where we begin the final portion of our approach. And you can see here is that they're leading you right on down the hypotenuse here. Remember, rise over run. Right on down the hypotenuse, passing these other waypoints to get you to a place to just above the ground to identify the airport and to safely land or go missed. You will also notice on this profile that they also give you the missed approach instructions here as well, okay? So when we look at the profile view, what we're looking at here is we're looking at, here's where we are as we start, we get our altitude and we know kind of what our course is going to be to get here to camps, to this intermediate fix or the initial approach fix where we start coming down, we're now lined up with the runway and we're going downhill to go land. This segment from camps to TEBS, we said was 9.2 miles, right? Right. 9.2 nautical miles. If you think about that, and if you have a ground speed of 120, you're talking about somewhere just about 4.5 minutes on a descent there between camps and TEBS. You can also now start seeing the distances here, but remember, the distance is going to be to the localizer. The localizer is at the far end of the runway. It's not at the approach end. So don't look at the distances here and think that's your threshold, because it's not. It depends on where the localizer is, and it is not uncommon for localizers to be positioned at a far end of a runway, okay? So here you have these, and we know that they want you no lower than 2,400 feet because they have that bar down below it. As you are now on your final approach course of 024, you're at TEBS, you're heading down the pipe. This is that point at which here at TEBS you will pick up and capture your glide slope. The glide slope is that part that we talked about that is going to give you the vertical guidance. Remember, the CDI that moves from left to right is going to capture the horizontal component of it. Am I on my course? Remember, that bar is your course. The glide slope, remember, is that bar or diamond or whatever indicator that moves up and down that tells you where your vertical component of your course is. If the diamond or the bar is up here, that means you're down here. That means you're low, and that's not a place you want to be. So you want to capture that, and when you have them positioned correctly, it kind of looks like a plus sign. So what it looks like is it looks like your localizer is lined up here right in the very middle of your HSI, and your glide slope is right here in the middle of the HSI. So when you have it set and you're flying down at the appropriate angle and speed and your the appropriate horizontal guidance, it's going to look like a plus sign. That's kind of what it looks like, a plus sign. And in fact, it's so funny because you'll see some of the older aviators and you'll kind of know who they are. They'll say, yep, I was glued to the approach. And you'll see them make this little plus sign thing here like that. Well, that's why they do it, is because in some of those older style instruments, that's what it looks like. In the G1000, it looks a little bit different. You have your HSI, which shows you here in the bottom here where your course deviation is, left and right, but then you also have to the left of your altimeter tape, you have another little box that pops up that has a diamond on it to the horizontal line. When that diamond is lined up on that horizontal line, you are set on your glide slope. If it's above you, you're low, go get it. If it's below you, you're high, go get it. Okay, so that's kind of where that is. It looks a little bit different, and I will show you guys what that looks like on a subsequent video when we look at this and show you what the proper glide slope looks like on the G1000. So with this here, now you are on the glide slope. Now it is a matter of energy management. Remember me telling you that so much of flying airplanes is that it's all about the molecule, and it's all about energy management. This is what you're doing now when you're landing this airplane. It's all about energy management, okay? So you're on your right speed, you're on your right course, you're got the right altitude. Everything is looking good as you come down. You're going to pass your various intersections. TEB is where you're going to start that initial approach fix. NOAC is going to be another one along the way. Here you have, again, it just shows you here where your localizer is. And with this one, you'll notice the various distances that you have. These distances along the bottom part are going to be those that are going to take you to the threshold of the runway. Okay? So that's kind of how this works to bring you down and to land you within the first. It actually will take you to the 1,000-foot markers. The localizer will normally take you to the 1,000-foot markers, which ensures the fact that you're going to land within the first 3,000 feet of that runway, okay? Or the first third of the runway, I'll put it that way. All right? So now we look down here below this profile. So now you guys can kind of see how we use this profile to kind of see what are our step downs, what do things look like as we're coming down the pipe here. Then the other thing that we see, and this is going to be that portion here where we reach this portion here, this is where we go missed if we are unable to identify the runway environment. We identify the runway environment with 11 different things, which we haven't talked about yet, but those approach lights are one of them. If we can see the rabbit, if we can see the Mauser leading us in toward that runway, we may not actually be able to see the runway threshold yet at a particular altitude, but if we get to that point and we see the chase lights leading us toward the runway, that allows us to descend an additional 100 feet in an attempt to see the runway. If you can't see it then, you go missed, okay? So that's kind of what that does. Remember that, is that if you see those approach lights there and you see the chase lights leading to the runway, you can descend an additional 100 feet, but no more until you make out that approach end of that runway. Then you can land. So you're always ready to take off again. It's why, again, we always talk about this, why you always have your hand on the throttle anytime you are at or below 500 feet AGL is for this right here. Well, it's for one of the things right there. So that's how that works. Now then, as we look below, we see another box here. This is 8. This tells us our category. What is our category? Well, as you have read from your reading, it has to do with stall speeds times 1.3 of your stall speeds puts you in one of these 5 categories. And in some cases, it can actually be more categories than that. But you'll notice that A is going to be kind of your slower movers. Most of your airplanes are going to be in A and B. Your big airplanes like a 757 is probably going to be in category C. A 767 is probably going to be in category D with these things. And so they have certain requirements that they have based on the speed of your airplane. So that's where these categories come from. And that was in your reading there with your chapters here with the category. Now, ILS runway 2, because remember in the upper right hand corner, we saw that we have the ILS or localizer. So what's the difference? We have ILS or localizer. ¿Por qué? Remember, the ILS gives you not just horizontal guidance, but vertical guidance as well. To fly this approach, let's say that the vertical component isn't working. Let's say it's out of service. It's not working. Can you still fly this approach? Yes. If the localizer portion is working, you can still fly this approach. But now, how is that going to take you down to that point of your decision altitude or decision height for an ILS if you don't have the vertical component? It won't. It can't. You only have DA and DH if you have both components working correctly for vertical guidance. Without the vertical guidance, you have MDA. With vertical guidance, you have a decision altitude or decision height. It means the same thing. One is just an international standard and the one is the US standard. So decision altitude or decision height. That indicates that you're coming down a precision approach, giving you vertical guidance and the horizontal guidance. If that's out, you can now fly this approach with just horizontal guidance, knowing what altitude restrictions that you have to not go below them. Those altitude restrictions are going to be a higher minimum than they would be with the vertical guidance. And here's how we can see that. If we're flying the instrument, the ILS, and we have both horizontal and vertical guidance, if we have both, we can take this airplane down to 254 feet MSL with a half-mile visibility. Half-mile statute visibility. So let's think about this. If we know that here our airport elevation is 54 feet, let's do some math. Where does this take us here above this runway? 200 feet AGL. And that is where most precision approaches, most of your ILS approaches, will take you down to 200 feet AGL. But we don't call it AGL for civil purposes, for civil aviation or general aviation. We take it to an MSL. And the reason being is because it can be confusing here, this 200 AGL versus MSL. Remember why I told you it is so important to have the correct altimeter setting on your airplanes, especially when you're flying an approach? This is why, my children, is to make sure that you can fly this thing down to this number, 254 MSL, with a properly calibrated altimeter. Without it, you could be lower than you need to be and hit something. That, of course, would just be bad form. Okay, so most ILSs will take you down to 200 feet above ground level to that runway. In this case, that's going to be 254 feet MSL. But Mr. R, what are these other numbers that I see over here that actually show 200, 200 and 1/2? Remember those frequencies that are pretty high over there? And I said that those are military frequencies. Military uses what they call, it's a ground radar system. So they can actually show information, AGL, because they have a ground radar. From the airplane, they can look and they can shoot the radar here to know how high they are above the ground, not just MSL. And I think some of the commercial aircraft have that as well. And so that's what that second number means. That second number is going to be AGL, not MSL. So remember, this is AGL, this is MSL, all right? And 1/2 statute mile visibility. What happens if they tell you you're starting your approach and they say, oh, by the way, visibility has fallen to 1/4 mile visibility? Well, you cannot legally land there because you have gone below the minimums required for you to shoot that approach. You got to go somewhere else, okay? So that's kind of what that means. So that is on an ILS. Well, let's say, for instance, that for whatever reason has lost the vertical component for that approach. Without the vertical guidance, without the glide slope, now you can actually fly this approach on a localizer basis in much the same way that you would fly a VOR approach. But notice now how far you can go down. Here you cannot go below 520 feet MSL and 1/2 statute mile visibility. And here, remember, this is going to be for ground-based, or not ground-based, but for ground radar systems. That's the AGL piece. So what that does is that creates a higher minimum. So if your visibility, and they have fog or they have some kind of something going on there where they don't have that visibility, the localizer may not actually get you low enough to land. If the visibility is not that big of a problem, then you should be able to use the localizer to be able to fly down to 520 feet MSL, identify the runway, and land. If you look above this here, you can see why they have these step downs through here. And they don't want you any lower than 980 feet. Why? I'll show you when we look at the visual approach coming in here. And so this is why they have all of these different numbers here, is so that if you're flying the localizer approach, then you know what your step down altitudes are between these various points. So you can kind of see now why you have to have a different rating to fly instruments. There's a lot of stuff going on here, my children. So, but it's very, very cool. So now we can see this. So here's what it is. So they have this broken up here. So they have for the slower movers in categories A and B, these minimums, and for the faster movers, they have separate minimums, but they're the same when it comes here to the localizer approach. Wow, I have just really messed that up there, okay? Now then, so we've talked about the ILS, we've talked about the localizer approach. Now we've got something down here that says circling. That comes in the next chapter, circling approach, because this comes into like the visual maneuvers that you have. Let's say, for instance, that the only approach that might be available to you is going to be the runway 2 approach, a localizer approach to runway 2, but the winds are actually out of the south-southwest, and they're too strong for you to land that way. So remember, we want to land into the wind. We're choosing runway 2 because hopefully most of the winds are kind of coming in here from the north-northeast. But if for whatever reason they're coming in here from the south-southwest, then the tailwind may be too strong for us to land on runway 2. Well, what do? This is where a circling approach comes into play. You fly the approach like you normally would. when you get down to a prescribed altitude, you are then able to fly a big circle out and around the airport, come back in and land on the opposite runway. So instead of landing on runway 2, heading off to the north-northeast, you're going to land on runway 20, coming back to the south-southwest. And so that's what a circling approach allows you to do. In order for you to do that, you have certain altitude minima that you have to meet. You have certain visibility minima that you have to meet, and you can never lose visual sight of that runway. If you lose visual sight of that runway on a circling approach, you got to go missed. And so it's kind of an interesting one to fly because you really kind of have to watch your altitude. You want to stay low because if you go back up into the clouds and you lose sight of that runway, you have to fly the missed approach. If you get too low, you can then potentially violate the principle of DHN. Don't hit nothing, because we don't want to hit nothing. So it's kind of an interesting approach. And you're making one big circle over here to kind of come in here and land this airplane. It has to be stable. It's got to be stabilized, but you are making a visual landing to be sure whenever you're using a circling approach. There are some things that you can do to kind of help you with some of your guidance, but you're hand flying this airplane to land this thing. It's no challenge at all. No challenge. It's not as big a deal in smaller airplanes, but when you're flying the big boys and you have to do this, I can see how that would be a bit of a challenge to fly that type of an airplane on a circling minimum. My guess is that you have certain carriers who say, we don't fly circling approaches. We just don't do it. It's there. It's legal. They can, but should they? You know, if I'm seeing a 777 kind of coming around here, 500 feet off the deck, making maneuvers like that, I'm probably going to watch that. So I'm just saying. So that is what a circling approach is. A circling approach allows us to use an approach to a particular minima, to a particular point, and then fly visually around to come back in and land on a different runway than what the actual approach plate indicates. It's perfectly legal. You can't just do it spontaneously. The tower needs to know what you're doing, but you can do it. But note the minima. In category A, which is going to kind of be us, the little bug smashers, you can go down to 520 feet. If you're flying at 120 knots up here, then you're going to have to, you won't be able to get as low. You got to stay higher. And if you're flying some of these bigger bad boys over here, you got to be even higher yet. So again, here's your 767 over here, here's your 757, and I don't know what the approach speeds are for a 777, but I can't imagine it wouldn't be between these guys here. My guess is here, this is probably going to be your F-18s, your F-22s, things like that. Your kind of your real fast-moving airplanes. You can't get as low to the ground because, again, you're moving at some pretty good speeds here. As you do this. And we'll talk about the circling approaches here as we get to this here in this next chapter. So just know that kind of that's what it is. Now, last box. The last box, well, I say the last two boxes. Here we have a small version of what the runway, of what the airport looks like. Top-down view of what the airport looks like. And you can see runway 2 here, you can see the Mauser here for runway 2, you can see the opposite end here, you can see that you also have runway 5, runway 23 over here. This kind of tells you where you're going to be landing, it kind of gives you that lineup that you have, reiterates the elevation and the touchdown zone information, okay? So it gives you some lighting information here as well with this. And so, yeah, that kind of gives you sort of a top-down view of what that airport looks like. They have a separate airport diagram, which we're going to look at here in this next part that we look at. But this gives you just a quick kind of a synopsis view of the airport as you're looking at the approach plate. Then below that, you also have this. So remember that we talk about some of the timing elements. Final approach fix to the missed approach point, 7.2 miles. Then below this, it gives you a speed here in knots, and it gives you a timing in minutes and seconds. So why is that there? Well, if we're flying this missed approach on a localizer basis, we want to know timing-wise, when should I be at a particular point, and how will I know? Here's where the timing comes into play. First of all, this speed in knots is ground speed. Ground speed. Right here, this is going to be a calculated ground speed. It is the only way that you can calculate time, speed, and distance is with a ground speed. The category speed here is an indicated airspeed. So this is going to be airspeed. This is ground speed, okay? Then when you look at this, if you do the math, and you say, okay, it's 7.2 nautical miles from the final approach fix to the missed approach point. If I am traveling at a ground speed of 60 knots, then it should take me 7.2 minutes to get there, right? Well, 7.2 minutes, first of all, 0.1 minute is 6 seconds, right? Because you have, you think about your clock and you think about what that's going to be. So a tenth of a minute is going to be 6 seconds, okay? 0.2 is going to be 6 times 2, so 12. 7 minutes and 12 seconds with a ground speed of 60 knots, okay? You can practice this on your E6Bs. At 90, at a ground speed of 90, it will be 4 minutes and 48 seconds for you to reach your missed approach point, your MAP, okay? So with that, that tells you from a timing standpoint how long that is. You guys have read the regulations. Why is it that you have to have a working timer with either a digital display or a sweep second hand working and available in your airplane for it to be instrument certified? It's for this. You have to be able to time these descents if you need to. You have to time turns when you need to. You have to know that if you're flying a hold, so let's say, for instance, that we see something here that talks about a 1 minute holding pattern, we need to be able to time that, don't we? So that's why it's important to have the ability to time something in the airplane. So that's what this part means. Now, your book will show you all of these things that you and I have just covered here with these. In the next part, we're going to be looking at the airport diagram, and we're going to be looking at how an ILS or a localizer approach compares to a VOR approach and an RNAV or GPS approach. There's a special chapter for GPS approaches. There's a special chapter for VOR approaches. But I want to introduce it to you before you see them so that those chapters hopefully make a little more sense. Whew. Anyway, guys, there you go. Remember, I told you how this was going to be. But it's just getting to the real fun stuff. Anyway, there you go, guys. And I will talk to you here on this next video. See ya.